The key to understanding a unit circle lies in using the special right triangles that we learned about at the end of the previous section. Also, we have to remember the trigonometric ratios and their relationship to side lengths. So just to give you a recap, one of the special right triangles, that's a 30, 60, 90 special right triangle. If this is 30 degrees here, this is 60 degrees here, and this is 90 degrees here. Of course, 30 plus 60 plus 90 gives us our 180 degrees. But what the special right triangle says is that if the hypotenuse here has a measure of 1 unit, then the length here, the longer length here, that is the square root of 3 over 2. That's the size of its length, and that is an exact value, root 3 over 2. We'll talk about its approximation in a little bit. And then the length here, this is going to have a length of 1/2. And of course, that's when the hypotenuse has a length of 1. The other special right triangle is the 45, 45, 90. If this is 45 degrees here, and this is 45 degrees here, and of course this is 90, 45 plus 90, that's our 180 degrees inside our triangle. But if this hypotenuse also has a measure of 1, then the length here is going to be the square root of 2 over 2, and the length over here is going to be the same. This is also the square root of 2 over 2. And these are exact measures for these lengths here. Again, we'll talk about the approximations in a little bit. So if you have a unit circle, and I'm going to use a graphic here, but you should certainly draw a unit circle. It'll give you a little bit more clarity as far as what's going on, but I'm going to use this graphic just for demonstration purposes. But if you can imagine, if this is our 45, 45, 90, and I'm going to sit it right here, where it hits the origin here. Don't forget, this is a coordinate system here. Then this point right here that sits on the circle, well, the x-coordinate comes over this far. And how far is that? Well, that comes over root 2 over 2. And then the y-coordinate, that comes up here. That's also root 2 over 2. So the ordered pair for this point right here, we'll wind up using our special right triangles to be able to determine it. And that would be root 2 over 2 and root 2 over 2. We do the same for the other special right triangle here. If I go ahead and put its point right there at the origin, and you can imagine if with this circle here, the hypotenuse here winds up being the radius of the circle. And of course, this hypotenuse here is 1 unit, thus the term a unit circle. And of course, the hypotenuse of our special right triangle winds up being the radius of the circle. So if I want to know where this coordinate is right here, well, I have an x-coordinate that comes over this far. That's root 3 over 2. And of course, it has a y-coordinate that comes up this far, and that's 1/2. So the ordered pair for this point right here is root 3 over 2 and 1/2. So now that we have that understanding, for this problem it says use the unit circle to determine cosine of 240 degrees. Well, cosine of 240 degrees will probably come in somewhere over here. So 240 degrees, it probably comes all the way around like this. That's our 240 degrees. This is 180 degrees. That's our straight angle. If it comes and stops here, that's 180 degrees. How about if I do this? So this is 180 degrees to here. And then this right here is another 60 degrees. So we can say that this point is 180 degrees plus 60 degrees. And of course, it's going to equal our 240 degrees. So if I was to put in a right triangle here, of course what happens is I wind up having a 30, 60, 90 special right triangle. Of course it just looks flip-flopped. It's just kind of flip-flopped along these coordinates here from what we originally had. But nonetheless, it's still a 30, 60, 90 right triangle. So since we know the pattern of a 30, 60, 90 right triangle, if this is 1 unit in length, then this length right here has to be 1/2. And then this length right here, again using the pattern of a 30, 60, 90, has got to be the square root of 3 over 2. Now keep in mind that we're trying to find coordinates here. This is in 1, 2, 3. This is in the third quadrant. That's where everything along the x-axis is negative. So we're actually going back. Even though the length is 1/2, we want to think in terms of coordinates. So this is actually going back. So this is going to be negative 1/2. And of course, it's going down. So this is actually negative root 3 over 2. So if I use the cosine of some value, we'll just label it as x. The cosine is the adjacent side, and I'm just going to abbreviate that ADJ, over the hypotenuse. That's what cosine is. Because I want to know what this measure is. I know that this measure here, that's our 60 degrees. But what is it for 240 degrees? So our cosine of 240 degrees that's the adjacent side. The adjacent side is this side right here. That's negative 1/2 over the hypotenuse, which is 1. Negative 1/2 divided by 1 is a negative 1/2. So we wind up using our unit circle and our understanding of special right triangles to help us determine the cosine of 240 degrees. And the cosine of 240 degrees is equal to negative 1/2. Now we can check that using our calculator. Remember that we have to be in degree mode. If you're not in degree mode, use your mode button. Make sure that you're in degree mode. Now that we're in degree mode, I'm going to go to cosine. Here it is right here. I'm going to type in cosine, and I'm going to put in 240. Make sure you close off your parenthesis and hit enter. And there it is, negative 1/2.